Hey there, Precalc kids. Today we are going to be looking at 3.5b. We'll call it story problems. Because you guys love story problems, right? Whoa. Okay. Here's the first story problem we're going to look at. This is our example one. Noteworthy little guy right here. This can be Richter, not Andy Richter. By the way, trivia question. Tell me the television show Andy Richter got his start on, and if you want, look up some clips on him. He's a pretty funny guy. Richter scale, that measures earthquakes, right? Like a magnitude 10's pretty much the most. Is actually found using logs. Like a earthquake that's if you have an earthquake that's a Richter of 4, you have an earthquake that's Richter of 5. The 5 is 10 times as damaging as the 4. So each time you go up by 1, you're multiplying it by 10. Okay. So your Richter scale, here's what they use to calculate it. Amplitude of the wave that's caused, because bigger the wave, the more damage is found. Your Richter is log of A over T plus B. Okay. That's a T by the way, not E. A is amplitude. Okay. So we're going to do this example. Make sure you have that written down, guys. It's going to come up. Let's try this beast. So the one in Garahat, India was 7.9. The one in Athens, Greece was 5.9. So we got to figure out what the difference was between those in terms of amplitude. Okay? So this is step 1. Our Richter 1, which we're going to say is Garahut, is log of A sub 1 over T plus B, which those are universal constants, so we won't worry too much about those, equals 7.9. And our Athens, I would actually use different ones. Athens Garo is log over A2 plus B equals 5.9. So what we are looking for, guys and girls, is the difference in the two in terms of intensity. So I'm going to subtract this equation from this one, so I get log of A1 over T plus B minus log of A2 over T plus B equals 7.9 minus 5.9. Okay? So again, I'm just subtracting these. If you want, I'll even color code this so it looks fancy. Make Christmas colors because it's right around the corner. Because this equation comes from the 5.9, the Athens. This one comes from 7.9, the Garahat. Someone tell me how to pronounce it. Give me a Jolly Rancher for it. Okay. So now, if I look at this beast, this side becomes just good old-fashioned 2, right? What happens to your B's? They go away, right? So you're left with log of A1 over T minus log of A2 over T equals 2. Right? Okay. What do we do with the subtraction? Subtraction, can we change that into division? So my log of A sub 1 over T, I'm writing the old-fashioned divide by symbol. A2 over T equals 2. Right? Because subtraction, I can move it in there with division, our good old quotient rule. Now remember, when you divide by a fraction, you actually multiply by the reciprocal. So what happens to your T's is they cancel. So you're left with log of A1 over A2 equals 2. Okay? Now, how do I get rid of log, guys? Here's where we gotta use some of that knowledge we got. How do you get rid of log? You take each of these as a power of 10, because remember, this is log base 10 then. Right? So these cancel. So you're left with a1 over a2 equals 10 squared. This tells me, I'm done, that the amplitude of the India India earthquake was 100 times greater than Athens. Here, watch this. I'll even do this. Okay. So that's what we're looking for. Some fancy math here. Okay. Okay. One other thing I want to talk about, guys, you're going to have questions about the pH scale, about acidity. Okay, pH is found by taking pH equals negative log of H plus. That's hydrogen ion concentration. Okay, that's noteworthy. That might come up in an example, guys. I'm not going to do an example, just know this equation for when you do your homework. Okay? Write it down. Write her down. That's called abstract art. AA. Okay. Next thing I gotta talk about is our good friend Newton. You may remember him in past physics classes, and there might be a certain ghost that have taught you about this before. Newton's law of cooling. Actually, I gotta do this. Write this whole piece down, guys. Noteworthy. While you guys write this, I got a little piece of music trivia. It's very, very old school. Alright, here we go. Let's take a look at this guy in action, okay? Interact. Let's bring him with us. Yeah, it's like the last example. I really like Newton's law of cooling. I'm gonna look for, I have a neat example with. This is the actual equation they use. If, let's say, your body temperature runs about 98.6 degrees, right? So, when a person dies, their body temperature drops, right? And it drops to the surrounding they're in. So you can calculate how long they've been dead by the temperature of body by using Newton's law of cooling. Okay? If you take calc, I do a bunch of examples with these. Or someday if I ever teach calc, it's pretty cool. You can also do it to how long a turkey is going to take to cook. How long they get their times on packages for how long it needs to be cooked to get to 160 degrees by using Newton's law of cooling. Okay, I think it's really neat. You guys probably think I'm a nerd, but that's fine. So we'd bring this formula with us. I'll be honest with you guys, I'll probably give you this formula on the test. So we have a hard-boiled egg that's 96 degrees Celsius, guys. So that's like 200 degrees Fahrenheit, so it is warm. It's placed in 16-degree water to cool. 4 minutes later, the egg is 45 degrees. Use the law of cooling to determine its temperature when it will be 20. So, what do we have? T sub m is the temperature of the surrounding medium. The water is 16 degrees. Okay, that's the surrounding temperature. Okay, and we're going to add to that. T sub 0 is our initial temperature. Okay, our initial temperature, what we're starting with, is 96 degrees Celsius. Minus. Again, I'm going to use my Tm again, which is 16 degrees. Okay, and I'm going to times that by e to the negative k. Okay. And what is my time? 4 minutes, right? What color am I using? And now, that is our current temperature, right? And our current temperature is 45 degrees. Okay? So what we need to do is solve for K, so that way we can plug in any temperature or any time and get our answer, right? Alright, get off here, Newton. Get out of here for now. Okay. So first thing I'm going to do is subtract this 16. Because it'll just make our life easier, right? So what's this become? 39. So we get 29 equals, what's 96 minus 16? 80? E to the negative 4. Okay. I just subtract these. I'm going to divide by 80 on both sides. Okay. So I get 29/80ths. I'm going to leave this as a fraction while I plug in my calculator, guys. It's going to make my life a lot easier. Equals e to the negative 4k. What do we do now? I have an e. I don't know how to get rid of it. How do we get rid of e, guys? You use natural log. That's the inverse. So you natural log both sides. Okay? And that's just some decimal, right? I'm actually going to leave it like this for now. What happens to my natural log of e? They cancel, right? Because that comes out in front. So I'm just left with negative 4. Okay. Okay. Now I divide both sides by negative 4. Right? So my k is equal to whatever natural log of 29/80 is, divided by negative 4. Okay? And I'm going to do some calculator magic right now. So okay, I used some good old-fashioned Wolfram Alpha, guys, and this is what I got for my decimal. Now, this is very important. You're going to say, okay, 0.25. No. When you're using natural logs, guys, you have to use at least 6. I want to use 7 digits. Okay? So my k is equal to 0.2536827. You may think I'm a little crazy for doing that, but it is very important. Okay? So are we done? No, because the question is, how long until the egg's 20 degrees? So we go up to our original formula, right? Now we aren't looking for when it's 45, we're looking for when it's 60 or 20. So we take this formula and we're going to write everything the same except instead of 45, that's going to be 20. Okay? In fact, watch this. choice, Mr. Twilliger. And I might also rewrite because you guys have to anyways. So 20 equals my 16 plus 80 E. 80 because 96 minus 16, guys. Now we know what K is. It's 0.2536827. Now we're looking for T. We're looking for time. How long till it is it? So I go through my same steps. Subtract 16. Subtract 16. 4 equals 80 e to the negative 0.2536822t. Divide both sides by 80. So I have 4 over 80 equals e to the negative 0.2536822t. Now what do I do to both sides, guys? I have an e. How do you get rid of e? You natural log both sides. Okay, so I'm left with natural log of 4 over 8. You might say, Schultz, why aren't you reducing it? Because it's pointless to. 2536822t. So these cancel now, guys. Natural log is your inverse of e. So I divide both sides by that nasty number. Six, 8, 2. 6, 8, 2. Okay? And that will be my t. Okay, and you're just going to plug that in your calculator. We'll leave it like that for now. That's your answer. Fun stuff, right? Let the complaints begin.